We gotta do the live now tweet, of course, as always. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this podcast is to learn a little something from each other. If you're listening live and you want to be a part of this little episode, why don't you send a tweet to PHP Roundtable with a question or comment, and we'll try to get it addressed on the show if we can. The HTTP protocol is the central nervous system of the internet. It is essential that us web developers understand this protocol kind of like with a deeper understanding than just sort of the surface layer. HTTP version 1.1 has been the backbone of the internet for about 20 years since its debut in 1997, and it's been very good to us. But there's a new version of the HTTP protocol on the horizon, one that totes better efficiency and security. Enter HTTP 2. HTTP 2 is already being widely adopted by some of the internet's biggest websites and is only a matter of time before we're going to have to implement it on our own web projects. For this episode, we're going to assume that you know a little bit, at least a basic understanding of the HTTP protocol and how it works and some familiarity with HTTP 1.1. But if not, hang in there. You'll still learn something. But now that we know what we're talking about, let's meet our lovely panel. In no particular order, we're going to kick it off with Davey Shafik. He's a developer evangelist at Akamai and release manager for PHP 7.1. Welcome, Davey. You're muted.
Hi, thanks for having me once again.
Absolutely. And we have also Ben Ramsey. He's a speaker, user group organizer, and blogger when he's not lazy. Welcome, Ben.
Hi, thanks for having me on.
Absolutely, and he's also memorized every RFC for HTTP protocols, I think, that have ever existed. He knows all the numbers to all of them. We also have Junaid Ali. He works for Cloudflare and works on standards for machine-to-machine communication. Welcome, Junaid.
Hello, thank you for having me.
Absolutely. Well, why don't we try to get the broader picture here. HTTP 1.1, it served us really well for nearly 2 decades. Why are we looking at a new protocol? Or I should say a new version of the protocol.
I think that the simple answer for that is that it has served us well only because we have forced it to do so. We have implemented a number of tricks over the last probably 5 to 10 years to stretch the limitations of the protocol in ways that was never really meant to be used. And now we're getting past that, and thanks to Google and their pressure, moving on with the web.
So you mentioned Google. What specific pressure did they give? They had their own little protocol, right?
Yeah. So Google created something called Speedy, SPDY, and they got up to I think the version 3.2 before they ended up folding it into what became the HTTP2 spec. But essentially, it's a more efficient wire protocol for HTTP that allowed them to give their users performance enhancements if the server supported it in Chrome.
Yeah, and I guess what really happened with the HTTP 2 spec there is that the working group who had been put back together to reform HTTP 1 was specifically not supposed to do a new version of the protocol. Hold on, I'm going to turn my audio off. I hear myself in my ear, and it's now getting annoying.
That's always it's like impossible to focus when you hear yourself talking back to yourself like a split second later.
Actually, there seems to be no way to do it while I'm recording. Anyway, so I'll just keep going. The working group sort of put together this, where they were a bunch of people who were put together to reform HTTP 1, and then as Google, who had a huge market share with their growing Chrome browser, was able to see real results from the new Speedy protocol, and were able to show those results to the world, the working group took a look at that and said, well, maybe there is a growing need for this, especially when Facebook and Twitter and others were taking a look at also implementing it.
And I think that's kind of part of the key. Like Google pushed out the browser with support for it, and then the larger sites went on and did the server-side part of it. So you're seeing actual adoption as opposed to, here's a new thing and nobody's using it, right? So real-world metrics really kind of push that forward.
So if we were to compare, go ahead.
So I was just going to say, I think it's important to note there's also, there are still devices which only support Speedy and haven't moved on to HTTP2, so HTTP 1.1 and Speedy. And it is possible, given the HTTP2 protocol, to support these. So you can concurrently support HTTP2 and Speedy. So it's an option that's accessible if you have a high traffic website and you do see particularly a lot of mobile devices which necessarily won't have upgraded to the newer HTTP2 protocol.
Do you know what the number of devices that are still Speedy only looks like?
I don't off the top of my head. We had a blog post which came out when at Cloudflare when HTTP2 was recently launched, but as a proportion of the internet, I think the dominant thing which is holding us back, I think, is Android web browsers. The non-Chrome Android web browser, which still represents a significant part of the internet, but doesn't necessarily support it. I think, given the evergreen nature of Chrome, it's quite rapidly, Chrome's quite rapidly, the majority of the user base has got up to sync with HTTP2. But as I say, I think there is still a proportion of the internet that does need to be served or Speedy rather over HTTP2.
One odd thing in that
go ahead.
is Safari on Yosemite, OS X Yosemite. The latest release, after they released, I think it's Safari 9 with El Capitan that included support for HTTP2. For some reason on Yosemite it only included support for Speedy and not HTTP2, which is a little weird. So there's a little odd tidbit.
My understanding was that Google was supposed to, by sometime this year, have switched all their properties and technology over to HTTP2 and phased out Speedy. But I don't know how much of that they've done.
They did deprecate it in Chrome itself. I don't know what they're doing server side. I don't think they've been public about that, but presumably it coincides with the Chrome removal. But that doesn't help with the older mobile devices that are still running either not Chrome or older versions of the OS.
I was always under the assumption that Speedy and HTTP2 were basically exactly the same, but just with a different name. So I guess that's not true. If you're stuck on Speedy, you can't just by default support HTTP2, correct?
Well, the upgrade string would be different.
Yeah. So they're similar. They kind of do the same sort of things, but it's essentially a new implementation of the same idea. There are several very important changes. For example, the addition of HPAT, which is a second RFC for HTTP2, which is for header compression. They ran into actually a security issue in Speedy with header compression, where, as I understand it, I'm not a security expert, and put that out there. There's an issue with when you compress something, due to the frequency of repeating strings, and then you encrypt it. It's actually much easier to decrypt at that point. Something along those lines, and so that's avoided by HPAT. So that's an important thing to have.
Yeah, we're going to get into some of these features like the header compression and stuff like that. I wanted to, before we did, I wanted to ask about if you guys know of how many websites out there are using HTTP2 as their sort of default protocol. Do you guys have any idea on some of the data about that, especially working at Akamai? No pressure. Akamai just seems to know all the stats on everything.
Yeah, so I don't have them to hand. I know that the big sites are all moving to it. So Google they're already serving HTTP2. Facebook is, Twitter is. If you're running a large-scale site, HTTP2 has significant benefits to you. If your user base obviously supports it, which 60% of current browsers out in the wild are supporting HTTP2. For concrete numbers, no, but all the big sites are doing it. When you tweeted the link to this, I think it was drugs.com mentioned that they just made the switch, which is pretty cool. So yeah, I mean it's Cloudflare has it on by default. So if you're using Cloudflare, then you're using HTTP2. Akamai does support it as a flip the switch, turn it on kind of thing. But the important thing to note is that default is kind of an odd thing here. So all browsers require TLS for HTTP2, so they're all using TLS, and as part of the protocol negotiation, the ALPN negotiation, which is the handshake, they negotiate HTTP2. So at that point, it could go either way, H1, Speedy, or HTTP2, actually. So it's not really default.
Yeah, I think one of the important limitations is that requirement for having TLS in place. I mean, work at Cloudflare, the amount of domains we see, we essentially serve more HTTP2 domains than anyone else. And the thing I see when I interact with the user base is trying to activate it is really getting people across the boundary from to turning on TLS on their sites and encouraging them not only for the benefit of HTTP2 but also the other benefits like Google using it as a ranking signal and the better security benefits which come from it. So I think this is one of the kind of final straws for people who are really on the fence about enabling TLS. I think there's very little logic now to argue, especially with HTTP2 and Speedy requiring TLS in practice. I mean, obviously the spec for HTTP2 says you can use H2C, you can communicate HTTP2 over clear text, but in reality, when browser implementation says in all cases pretty much you have to use TLS, it locks off those performance advantages to website owners who aren't willing to move forward to having a universal SSL or TLS implementation on their site. So what I'd really say is this is something, if you don't have TLS right now, it's something you really need to look hard about and see whether it's finally worth pushing yourself over the finish mark.
Yeah, I mean, at this point, there's no reason not to have TLS when you consider that you can now get them for free through Let's Encrypt. You know, and automate. Sorry, my accent's all weird. And automate that process. In addition to that, the multiplexing stuff, which we'll probably get into with TLS, with HTTP2, negates the performance overheads that usually come with TLS, where you're creating multiple connections and having to verify that, you know, that handshake a lot. There's just no reason not to use TLS. And then there are other features, like, for example, the new location APIs in JavaScript. You also need TLS now to start using those in some browsers. So, you know, it's not just going to be HTTP2 is the reason to get it. Any time that I think browsers are going to be implementing features that reveal personal information, I think they're going to start locking those behind HTTPS as sort of a part for the course standard thing now.
Yeah.
I was
Go ahead.
I was just looking up the number for what you were asking, and according to the w3text.com website, HTTP2 is in use by 8.2% of all the websites they survey, and that's as of June 16th. And I think that involves something like 1 million or 100,000 websites. So I need to find that number, but
I think it's
that number keeps going up.
Million or something. That is the Alexa rankings, right?
Yeah, I think so.
And so if I wanted to start serving HTTP2, can I do that with 1.1 as well, like simultaneously?
Absolutely. That's a key point of HTTP2 being backwards compatible. In fact, by default, you're always going to be backwards compatible. It is possible to have HTTP2 only, and there's a performance benefit in that using prior knowledge, but the expectation is you're going to have both.
In fact, the expectation of the first request is that it's kind of a two-step request. So you would make the request one first, right?
Only if it's H2C, if it's over clear text. So if it's TLS, you're doing that negotiation in a handshake, the SSL handshake, or the TLS handshake, sorry. If you're doing plain text, then yes, you would actually issue an H1 request and then upgrade. So yes and no.
By the way, if you're listening in your car or whatever, and you've heard TLS dropped a lot, I know I know Davey and Junaid also kind of mentioned SSL. So if you're kind of confused by that, it's basically getting your site behind HTTPS. We used to say SSL back in the day, but SSL is dead, so now we're saying TLS. So if you missed that transition, that's why it might be kind of confusing when we keep saying TLS, and in terms of like security and things like that, and getting it behind a secure connection. Just wanted to clarify that, just in case you missed that transition there. I wanted to see about what features PHP has to support HTTP2. Do we even need to worry about this version upgrade within the context of our apps, or does this kind of happen behind the scenes without us even knowing that anything's changed?
So this one is near and dear to my heart, but I don't want to kind of bogart the whole conversation. So if somebody else wants to start, then
I mean, I'll jump in with something that's not dependent on PHP, but is something you can do from PHP, and then you can talk about what you're working on.
Okay.
Within PHP. So some of the things that you can do with HTTP can just be done kind of at the header level, and you've got this later on your list, but that's the server push. So there is a excuse me, there's a standard recommendation for server push using a link relationship called Preload. And if you send back headers with link headers with a preload relationship on these links, then the server will pick that up and automatically just start streaming the rest of those assets to the client. So this is a way that you can go ahead and indicate to the server what it should go ahead and just send all back. And you can do this from any server-side technology.
So long as you're using Apache.
What
sort of? So support for server push is not in Nginx yet, which is
right, and this hasn't been accepted yet.
It is part of the standard spec.
I don't think it's been fully accepted yet. Has it?
I'll double check on that.
I think it is in the RFC.
Yeah. So as I said, Nginx doesn't support server push. I have talked to them numerous times. It's not even on their roadmap at this point. They do support everything else in HTTP2, but not server push. But Apache does, and then there are options such as H2O and Caddy will be supporting server push soon, I believe. But basically, proxy servers that will do the H2 side of things for you. It's completely.
I'm sorry. When I was talking about draft form, I meant the preload link relationship is still in draft form.
Two things going on with that. There is client-side preload, which is when the browser gets the header, it will start pulling the assets before it started parsing the other content that's coming. That's actually HTTP1 compatible also. There's nothing to about that specifically. They are co-opting that for server push as well, with the idea that essentially you can push or you can pull. It doesn't really matter in that context. It is essentially getting the assets down as quickly as possible. I have a philosophical difference or problem with that. I think it should be rel equals push. As they've just now added rel equals preload no push to specifically not allow pushing. And Michael, there's obviously a difference there. So you should not do the same thing. But yeah, so that's what you're talking about.
Yes.
That's part of pre-browsing, which is really cool.
So Sketch on Twitter said, for curious people, there's a Chrome extension that tells you if sites are using Speedy, HTTP2, or both or neither. And this extension is called HTTP2 and Speedy Indicator.
Yep.
It's kind of cool. But back to the... Go ahead.
You can also see it in the dev tools as well.
Okay, cool. Back to the question about the PHP support for HTTP2. Dave, you said you had some things that that were near and dear to your heart about that.
Yeah. So the first one is related to what Ben was just talking about. So my initial kind of foray into HTTP2 and PHP is the support of server push as a client in curl, the curl extension. Which, if you are someone who doesn't like curl, it's honestly like I've fallen in love with it over the time I've been working with it like lately. So basically just support for handling pushes if they're pushed to you from a server in curl, and that will be in 7.1. The problem then became, how do we test this? We don't have any HTTP2 servers, so I looked at, I should say, we can write one in userland, which is meh, or we can support it in the CLI server. So I'm working with Pierre from Microsoft, and we're hoping to bring the CLI server into HTTP2 land. We want to continue supporting H1, mostly because the H2 server is going to bring some dependencies with it, which are kind of heavy. There's lib ng-http2, which ng-http2 also is an amazing project for proxying and being an HTTP2 server. But they have a library which works both client and server, so we're going to pull that in, and by necessity for browsers, we're also going to bring in an SSL library, starting with OpenSSL, because that's what PHP generally has. And so the goal is to then have the CLI server support both. So if you compile with HTTP2, the CLI server will support HTTP2, hopefully with flags to turn it on and off, so you can test things like fallbacks and all this sort of stuff on the command line. And then I want to take that further. I want to rewrite the streams layer on top of libng-http2. If we've got that huge dependency in there, and it is a solid, rock-solid dependency, we should be using that to support HTTP2 on the streams layer. That would again be transparent. And then finally a libng-http2 client, like an extension. So that would actually be a replacement for curl, or in addition to curl. It's a different interface for HTTP2 clients. So there's a lot going on with that.
Didn't you add support to curl for that, the PHP extension?
Yeah, so that's what's going in 7.1, the server push stuff. But I mean, it necessitates that you compile libcurl with ng-http2 and SSL, and by default, I think Debian and Ubuntu and Red Hat all kind of do that. But if you're compiling by hand, you may not. Or if you use Gentoo, say for example, where it strips everything unless you explicitly add it. But yeah, so that is going in 7.1. That will be in 7.1, but it's only the client side of stuff. On the server side, we need to do a little bit more. So
that ng-http client.
Yep.
I'm getting tongue-tied here with all these acronyms. That client's really cool. You can use it to test an HTTP2 server, and then you can see all of the different I'm sorry, not streams.
Frames?
What do you call the? Yes, you can see all the frames, and then it tells you what kind of frame it is and all the data on it. It's pretty cool.
You can also tell it to like listen for multiple pushes and stuff like that, like how many handlers and stuff, and you can see all that stuff happening. It is really cool.
Yeah. I was just going to say, I'm quite liking, there's quite a high-level debugging tool called H2C, which is written in Go, and H2I as well, which I'm quite liking the way they tend to operate. I mean, it doesn't obviously integrate with curl as well, but they're definitely available if you I'm tending to write and Go a little bit more, and they're really, really good clients. So if you're looking for one.
Nice.
The nice thing about curl is that it has like 40 different language bindings, and like if you're doing HTTP2 stuff, it's pretty simple. But yeah, something like a language like Go, which is written the way it is, and you write Go in the way that you do, kind of lends itself to the asynchronicity of HTTP2. And it's a wonderful language to work with HTTP2 in.
So, David, when you said that you are bringing HTTP2 to the CLI for PHP, do you mean when you're starting the PHP server with PHP-S?
Yeah. So my goal is to. There's an RFC for this. It is not yet proposed, like for voting or anything, but there is an RFC. So my goal is to basically have an HTTP2 flag to turn on and off H2 support. As I said, part of the thing that we're going to have to do as we're writing clients is ensure that they do fall back properly. If the server only supports H1, so being able to turn that on and off is pretty important. But yeah, otherwise that's what it's going to be implemented into. My hope is that we can just leave the old sort of code path in place and fork out, not literally fork, but code fork into the HTTP2 libng-http2 stuff if you compile that in.
Cool, cool. Well, I do want to talk about some of the specific things, some of the specific features. We've already mentioned some of them, but some of the things that make it HTTP2 different from HTTP 1.1. I hate saying HTTP because it's HTTP.
H2. This is why they've come up with H2. H2 is the way to go.
It's the most annoying thing to say ever. So one of the things that you might have already heard as a listener is that it's multiplexed. What does it mean to be multiplexed? Why is that? What is that, and why is it better than what HTTP 1 does? H1 1.1.
I can take that. Ben's just posting links.
There's an internal chat here, and Ben's been posting links like crazy. It's great.
So it's important to understand the way that the protocol is written. So essentially, the very most basic part of the transmission is what's known as a frame, and a frame will stand for several things. So it could be, say, a header section, or it could be a body section, or settings, or there's a whole bunch of these. There's one for pushes and all this kind of stuff, closing connections, etc. Because we're sending now very small, discrete binary packets, essentially, these frames, we have the ability to interleave those when pushing content down to the user. And with that, we can interleave frames related to different requests, essentially, or different responses. So each request response is part of a stream, which is made up of multiple frames. They have an identifier. Each frame is tagged with which stream it belongs to, and you just send those streams in whatever order you want. And on the client side, it then pieces those together into a contiguous stream of data.
And that happens with one TCP connection?
Yes.
So is that's the main benefit, is that you don't have all these open TCP connections for all these different things, right?
Yeah, so I mean, currently browsers have a limit of 6. I think IE might have 8 connections to a single host. So we've built in things like domain sharding, right? So that we can have multiple, more than 6 requests for, say, things like static assets and whatnot. This is one of those hacks that we have in place to make H1 work for us. With multiplexing now, we can shove it all down one TCP connection. There are some limits on that. So I've seen just yesterday, like Nginx defaults to 128 streams per connection. Chrome is 256, I believe it was. I was reading, maybe it was Firefox. So there are some limits, but certainly not 6. It's within practical realms now of doing everything we need within one domain. So actually, domain sharding can potentially be a anti-pattern moving forward, because now we're opening up multiple connections that we didn't need and doing multiple SSL handshakes if those things are on SSL domains and stuff.
And most of all the hacks. I'm sorry, Junaid, go ahead.
Sorry, what I was going to say is one of the things with domain sharding is obviously multiple origins. When you're dealing with a multiplex connection and you're dealing with a single connection, it can only be to one origin. And there's quite a nice internet draft which is surrounding secondary certificate authentication. And it's not an RFC yet, but what it essentially allows in a connection is it allows, if you're connecting to one origin and it's able to assert its ownership over another origin, you're able to essentially use the same HTTP2 connection when you're communicating with that origin. It also fixes some things like SNI and X509 authentication in HTTP2. So that's quite an elegant one. But I think one of the things I'd also mention is it's very important to mention that HTTP2 is a binary protocol. So with that, you do have to be extra careful with debugging.
Yeah, that's a good point. I do want to talk more about the specifically that it is binary and how to debug that and stuff. But if I'm trying to just envision what an HTTP2 request and response would look like from the perspective of 1.1, I'm thinking in 1.1 I've got my request, so I've got my verb, my get, the thing that I want at the host, and whatever other headers I want to send with that, and then I get the response, and it's just one giant text blob that I can read and I can parse, but that top part is that header, and you got the 2-line carriage returns, whatever, and then you've got your body. That would be a typical way I would think of a HTTP response and request and response. How does that differ in HTTP2? What kind of things would you see or request?
I guess that. So I was just going to say, at that high level where you see that the request and what you're getting back, there really isn't much of a difference, because when HTTP2 really puts on a one-to-one ratio at a high level onto HTTP 1.1. So I guess for the high level, for the everyday PHP developer, you aren't really likely to have to encounter anything too different. I'm not sure if anyone else.
You're not going to see changes, but if you're trying to look at the request over the wire, it's going to be pretty different. Your headers are going in a different frame. And in fact, that frame can be reused because a lot of headers get reused on multiple requests. So that's kind of a benefit there. So they're going to be separated out. They'll have an ID on them, and then you're going to have your the content frame. I can't remember the name of it.
Data.
But it's going to be related to the header frame, right? Or the stream. They're going to have a stream ID, so that they're all related.
So the most important thing to understand is the semantics of HTTP1 still apply with HTTP2. So you've still got all the verbs, you've still got all the statuses, you've still got all the different parts of the message. The difference is in the actual wire protocol delivery. Some things that are consistent. So headers will always come towards the beginning of the stream, for example, before the body. But otherwise, the protocol itself, unless you're writing an actual client or server, you're not going to see any difference, except for the fact that you may be dealing with multiple requests and responses at once, which is the same as doing, concurrent stuff in H1, essentially. So that again is not different. If you are just doing a single request, getting a single response, the semantics are, for all intents and purposes, identical.
Cool. So it's good to know. So is there when you said it has an ID, what kind of ID is it? Is it like a UUID or something, like for the headers and things like that?
I believe so.
Oh, it's I'm looking at NG-HTTP2, and it looks like a numeric ID, but I'm not quite sure what it is under the hood.
So if I use, for example, like Postman or something to like debug my API right now, or I'm just like poking endpoints, if I'm using HTTP2, that shouldn't change too much the way I use that, right? Like that Chrome extension Postman to kind of like poke around on things.
Completely marshal all of that for you. You're not even to see it.
Cool.
Right.
What about like a hat or something, like for acceptance testing for your APIs?
So what you might see, sorry, going back to Postman, what you might see is headers prefixed with a colon. Those are the ones that are coming from the HPAC type table stuff that we can maybe talk about. Those are essentially just sent over in a special way, but they are essentially the same thing. As far as something like BHAT, your automated testing, again, if you're not writing the actual client or server, you're not looking at the wire protocol. The semantics are identical, so you wouldn't see it. So if you're using, like Guzzle, for example, which does support curl and has some sort of support for HTTP2, and you were to make an HTTP2 request, your code is not going to change in any way whatsoever. Curl is completely handling that and making it transparent. So yeah.
Cool.
Yeah. So actually, there's a diagram in the RFC 7540 at section 4.1. It kind of shows a diagram of what all the different of how the payload looks. It has like a length. It has the type of the frame. It has the flags, and it has a stream identifier. I think that's 31 bits for the stream identifier, and so forth.
Cool.
I was just going to say, if anyone is tempted to write their own implementation of the RFC, there's a tool called H2Spec which you can test your server against, and that will ensure that it is watertight and your kind of clients won't have to see anything breaking or have to encounter the low-level stuff. So if anyone is at that level, H2Spec is a great tool.
Nice. That's cool.
So we mentioned server push, and that's sort of a way that you can basically tell within a request that, hey, expect these assets. So like in a typical web environment, and if I'm like on my web browser and I request a site, it has to sit there and download the entire all the HTML for that website, and then parse like what CSS documents you need, what JavaScript you need, all the images, and then only after it parses all of that and figures all that out, then it requests all that stuff. But in HTTP2, you can send all the assets along within a header, right? Like that says, hey, you need to download all of this JavaScript and these images right out of the bat before it even parses the initial request. Is that right? Is that how that kind of works with server push?
So the header stuff is the initiation for the server-side part of it. That's not actually how push works. So the way push works is piggybacking on this whole frame idea, on this interleaving of frames and multiplexing. It essentially sends a special frame called a push promise that says, hey, I have this thing, do you want it? And then the client says yes or no. And if it says yes, then it will just send the response and request as if the browser had or client had requested it. And then the client, if it was a browser, would actually cache that until such a time as it actually needed it. So your example is perfect, though, in terms of you would send an HTML or request an HTML page. The server would start sending that back and say, by the way, here's all the CSS, here's all the JavaScript, here's all the fonts, etc. And then the client is going to be in control of saying, oh, yes, I definitely want the CSS, I definitely want the JavaScript, and cache those. And then as it makes its local requests, as it actually needs them, it would pull it out of cache instead. My experience on writing programmatic clients is you would just have it in memory and just deal with it. You're not actually caching it anywhere.
So you guys mentioned preload earlier. Go ahead, Junaid.
So I was just going to say, there is an option for the client. There's a frame they can send back called RST stream, which basically, essentially tells the server to stop pushing data if it's already kind of cached already. There are cases where that data will sometimes be pushed, and the frame is sent after that data has been pushed, where you can't really do anything about it. But there is an element of control that's available there for the client.
That's cool. So you guys mentioned preload earlier, and how does that, is that related to server push at all?
Yeah, so when you send a preload header or a preload relationship link in a link header from the server, your server, Apache, picks that up and then uses the push promise frame that Davey was talking about to go ahead and send that asset back to the client.
This is the language level informing the web layer, not the client that it wants to push. So this is PHP, say PHP FPM, informing Apache that it should go and push this to the user. It would then actually strip that header. It would never actually make it to the client.
Gotcha. And is that done automatically, or do we have to manage those ourselves as developers? Say like we need to like explicitly say download this resource, this resource, this resource.
So I think we're all learning here. This is something that I'm spending a lot of time on. So it would be fairly trivial, for example, to modify some framework's asset manager where you're loading in stuff into the header, of an HTML page to just go ahead and add those link headers. And that's certainly an approach that you can take. But I think that there are options to be a lot smarter about this. We have options to do things like pushing critical paths. So we have one of the other tricks that we have with H1 is what we call critical path embedding. So essentially you take the CSS and JavaScript necessary to render just what is visible on screen when the page first loads, and you embed that, hard-code it into the document itself so that it's there. There's no additional requests that have to be sent or dependencies that are necessary to render what's visible on screen. With server push, you could send those two things, your JavaScript and your CSS critical paths, as pushes, small pushes, that would be very quickly downloaded, and then follow that along with the remainder of your CSS and JavaScript, for example. So you can automate it. There certainly are ways that you can do that. You can automate even critical path type stuff. What I'm really interested in seeing is machine learning around some of this stuff. So for example, especially when it comes to APIs, we can start to observe client behavior. So whenever this resource is requested, generally other requests to XYZ sub-resources are then requested. We can start pushing those instead, right? We learn those patterns, and we can start pushing based on those.
You think web servers might start building that into their own software, or do you think that's more of an application level thing?
I'm hoping, and don't take this for what it might sound like, I'm hoping it will be at like the CDN. Right? I'm hoping that we can be smart because we're doing a lot of the caching, and we're sitting there in front of these applications and seeing tons of traffic. So for example, we can start to look at things like WordPress as a whole, as it's an entire install, and go, well, if you're hitting WordPress, then you're definitely going to hit these kind of things, etc. We can make those kind of large-scale decisions and be very smart about it. Otherwise, I think it would be, I don't know. I don't see any problem with any layer doing it. Like, I have no problem with the language layer doing it. As a developer, like doing it manually, obviously that's like the most amount of control. Writing the code that would automate that would be kind of a pain, but if it's in a framework, it's done. The web layer, of course, sees multiple requests depending on how you're farming those out and scaling that. It could be dumb to do it that way. It might be better to do it, say, your load balancer or something like that. There's many levels where this can be put in place. But I'm hoping that CDN functionality is going to going to jump on that.
Well, that could really transition us into kind of the last thing I wanted to look at, and that's what are some of the common practices that we implement in HTTP 1.1 that try to make things more efficient, like concatenating our files and image spriting, so that you've got all your images in one file, and then you just use CSS to position it, and do like hover states and all that kind of stuff. Are any of those are those bad ideas on HTTP 2?
Potentially.
Yeah.
I think is the right answer, right? So I have been saying that, like, in its purest form, yes, those should be less performant, etc. So, for example, sprites seem to make sense, but very often what we see with image sprites is we send way more images than we necessarily need for any given page to get it into cache and to remove overhead later. If we were sending small images individually, just the ones that we needed, and doing pushes, then hopefully we're being more performant that way. However, there was an article out yesterday or the day before, I'll find the link for you, that said that actually this still ends up being faster using an image sprite. So I think that it's going to be trial and error. This is something that nobody has figured out yet. This is still such a young technology.
It's thought that the domain sharding would definitely be less performant because you're still having to open up multiple connections. However, if we end up being able to use the same connection for multiple origins, then, as Junaid said, that might not be an issue either.
Right.
So I think in its current state with domain sharding, you're essentially having to make an unnecessary DNS query and an unnecessary TCP connection, then an unnecessary TLS handshake, which is, I guess, one of the problems when you've got so many sites which are pulling in, say, Facebook like buttons and all the rest. And I think the ability to serve multiple origins definitely down the CDN is one room for improvement for HTTP2. But I guess on the flip side, concatenation as well, I'd say that's something you should start to veer away from as well, because as soon as you start concatenating, say, CSS files, one small change in one CSS file or one or an unnecessary file in one page, you end up having to serve all that data afresh if you've got it cached on the browser, or you end up having to serve all of it for a single page. So I think those are kind of bad practices, but when it turns to minification with gzip, I'd say that that's definitely still a good practice. That's something you can still benefit from. So I think it's a hit and miss case of each individual practice has to be assessed on its own merit, really.
Yeah, I absolutely agree. I mean, the statistics say that if you're gzipping, the amount of benefit that you get with further minification in terms of like stripping out white space and all this stuff is like 1% extra. It's actually not necessarily worth it. One of my big things, one of my big things is making things easier in terms of deployment and stuff like that, development and things like that. We have a whole bunch of processes through Grunt and Gulp and all these tools to manage all of these changes and things like that we can hopefully get away from. And if there's fast enough and fast, right? So I think that we're going to be at the point where we're fast enough with H2 with no extra work to get rid of all that extra overhead of handling all of this stuff. And then we can start to build new best practices. But to answer your very initial question of things that are potentially bad actors now, we've already covered domain sharding, minification and concatenation, image sprites, data URIs, critical path injection. I think that's probably most of them that you're going to start seeing at least being reevaluated. Certainly should be reevaluated moving forward.
By the way, if you're not familiar with domain sharding, it's basically this idea of taking, right now there's a limitation with the number of TCP connections you can have on a single host, and browsers will limit that. So in order to get around that, when you have lots of assets that you want to download from a single, say, CDN or from your own website, like say you have like tons of these images in JavaScript and CSS, you can actually set up these aliases to like maybe subdomains on your domain name, or send it to different CDNs. So you're basically sending only at like 3 assets with one subdomain and 3 assets with another one. So that way you can kind of use more TCP connections and get around a hacky way to get around your limitations on your browser.
I was just going to add, I think it's it's important to note that the rules of physics are still a problem. So I'd say HTTP2, and people who say just use HTTP2, don't use a CDN, that's the wrong kind of approach. There is still the speed of light problem when we're dealing with content delivery. So yes, HTTP2 can offer some benefits at the communication layer, but ultimately serving your content from a closer host will benefit you.
Yeah, absolutely. I mean, obviously, myself and Janae both work for CDN, so we're a little bit biased here. But yes, no, the closer you can get these things to the user, the better. I'm hoping, as I said, the role of the CDN is going to evolve to automate a lot of these best practices, and also be involved in like the mitigation of migrating to, between the versions. I'm hoping that we're going to start seeing some smarts in terms of, if you have an H1 client coming in, then you're going to be doing the minification, all this kind of stuff that you did before. And when you see H2 clients coming in, then you're actually going to be serving different in a different way, in a way that makes more sense for the protocol and everything that it supports.
Yeah, I agree. I received a question at the iMasters PHP Experience conference in Brazil, and the question basically asked, are CDNs going to go away because of HTTP2? And I thought that was kind of a little bit funny, because I think that CDNs stand to have an even greater place to help people use HTTP2 and streamline it for everyone. And maybe some of this kind of machine learning stuff you were talking about earlier, Davey, can come into play with a CDN helping to figure out which assets should go.
I think another thing which is quite, sorry if I cut you off, Davey, but I think another thing which is not possible at HTTP2 layers is differential compression. You can't, if you've got an origin and you've got a CDN, in that case it's possible you can just send the differences to the CDN if a change is made, say for dynamic content like HTML. No matter how you're dealing with HTTP2, you can't really do that without a CDN in the middle. And the CDN ultimately should act to reduce the amount of load on the origin as well. So being able to deflect a lot of the work like redirects, like protocol upgrades and all the rest, I think you almost end up with your CDN acting as a piece of middleware. And I think that's where there's really room for improvement there.
So I think there's also two things I want to add here. HTTP2 and WebSockets, don't think that those things are replacing one another or anything like that. They're different purposes, different things. WebSocket still applies in the same way it does with H1. That's a question that I always get whenever I talk about HTTP2. And the other thing is, I want to reiterate, 60% of browsers that are in your user's hands are supporting HTTP2, and it's essentially there's no loss to turning it on. If you are able to serve a request as HTTP2, the benefits of the binary protocol being more efficient to parse on both ends of the request and the response mean that you are saving resources by using HTTP2. And there's no friction to turning it on. So you should just go ahead and do that.
And so I should be able to just, if I'm already serving with Apache, for example, I can just turn on an extension or something, right, and enable it?
Yeah, there's mod HTTP2. It's built in. You just turn it on. Nginx has had support for it in the last few releases, again, without server push, but otherwise support for it. And H2O is my kind of suggested, recommended proxy. If you don't want to actually do it on your HTTP layer, you can do it as a proxy. Or turn it on and proceed.
According to caniuse.com, 63.07% of browsers support HTTP2 fully, and 6.8% support it partially.
And there's partials of Safari, which is what I use.
Right. And IE 11.
So Phil Shipley on Twitter asked, if Cloudflare is serving HTTP2 for me already, does it help performance if the origin also serves HTTP2?
Yeah, it would help the communication between the our end and the origin server. But I guess if there's cache hits, if there's stuff which was directly being served from us. So if you choose to also cache your static HTML with us alongside your CSS and JavaScript, and you're very rarely hitting your origin web server, then your room for improvement is going to be limited. But it'll make some beneficial improvement, I guess.
Yeah, actually, I was curious about that too. We used CloudFront for a lot of things, and wanted to know, like, if CloudFront was switched over to HTTP2, which it's not right now. Do we take an immediate advantage of that as a proxy, or like a reverse cache proxy, or do we still have to be serving over HTTP2?
It's still going to be hitting your origin using H1 if that's what you only have enabled.
Right.
It's not going to change your origin in any way whatsoever. It's just the end users then are going to be able to use HTTP2. But yes, there's definitely potential benefits for having it on your origin as well, especially for things like cache stampedes, right? Anytime that you can minimize the amount of resources necessary to do the work is beneficial. So, yeah, definitely on your origin as well.
Yeah.
Cool.
I mean, I've spoken to a few people recently who've been saying, you know, I've got this physical load balancer in my building and it's running this ancient firmware. And in those cases, the only realistic avenue is upgrading or putting a CDN in front of them, like Cloudflare or Akamai, which does support HTTP2. And even in those situations, you do see a huge benefit, really. I haven't seen too much of a improvement difference, to be honest, seeing people turn it on from their kind of the origin as well. But I guess there's some improvement there, because I guess in most hosting situations you are dealing with, you know, pretty vast connection speed between your CDN and your origin, so that's quite rarely the limiting factor. But I mean, there is still room for improvement there, but the immediate advantage we saw when we turned on HTTP2 for the proportion of the internet we serve was sites immediately getting dramatically faster, regardless of how they were set up, providing they had universal or they had SSL on their site and it was being enforced. Then we saw a performance improvement regardless across the board.
One of the things we're looking at Akamai with H2 on the origin is using things like server push and things like that to actually inform the CDN in terms of decisions that it can make as well. So, and also, like, if you want to be forwarding on things like push, we would potentially take that from your origin and forward that on to the end user at the edge as well. So, you know, if you want to start taking advantage of those things, you do need them at the origin to make sure that everyone knows what's going on.
Yeah, I mean, one of the things we've supported HTTP2 server push at Cloudflare. I mean, one of the difficulties with it is people do need to make an active choice to send those headers. But I mean, where they do, I've seen about alongside the improvement with HTTP, when they add server push on for all the assets on a standard web page, I've seen as high as a 2/3 decrease in page load time, so it's definitely worth investigating.
And so for us developers, we just enable it and then start automatically benefiting, basically, is what you're saying.
Pretty much.
A large part of it is that, yes.
That's awesome.
I think it's all very immature. We as an industry don't really know best practices yet. We're all exploring this together. And I think over the next year or two, we're going to see some best practices start to come about in terms of how we actually start serving pages and what those new architectures look like. Probably a good time to plug the fact I'm working on a book that answers hopefully some of those questions. So, you know, I'm very into this right now, and it's a really cool space to be looking at.
Awesome. Well, looking forward to the future. Is there expected to be an HTTP 3 anytime soon?
I mean, sorry, what I was going to say is, I guess the benefit of HTTP2 is if the upgrading methodology, which is in the protocol, if that proves to work well, it may be quite an easy upgrade to HTTP3 if it does come out.
I think that the working group. Oh, sorry. Go ahead.
They're very specific that it's not HTTP 2.0. So I think they've adopted like the Chrome methodology, so we're not going to see a 2.1, we're just going to see a 3 if we are going to see improvement. So putting that out there. Anyways, Ben, go ahead.
I think the working group worked hard to make it so that the next version can come quicker than 20 years. Especially if you take a look at all the updates to HTTP 1, they didn't really change the spec too much, but they added the concepts of all these registries. And so we now have centralized registries for headers and status codes and caching algorithms and all these kinds of things that will allow us now to add more on to HTTP without having to put out ginormous RFCs. And then subsequently to that is the upgrade methodology. So now we'll be able to have servers who can say, you should be able to upgrade to HTTP 3 or 4 to talk to the server.
What's really exciting me at the moment over HTTP 2, it might be me putting on my security hat, but I think TLS 1.3 and the standardization of char and poly as encryption ciphers, where that can improve performance quite dramatically on mobile devices. I think that's what's kind of exciting me at the moment above the deficiencies which there are in HTTP 2. So I'd say personally that's what I'm looking towards.
Cool, that. Sweet. So I want to actually start wrapping it up here, but I want to take two tangents that weren't on the official show notes, so sorry to put you guys on the spot here. But I specifically have some questions for Davey and Ben. But like first for Davey, since you're the 7.1 release manager for PHP, what's the what's the status of 7.1 at the moment?
So Alpha 1 came out last week. We are now working our way steadily towards Beta 1, so we've got at least one more Alpha before that. Once we hit Beta 1, we'll be in essentially feature freeze, and we'll start wrapping that release up. We are on schedule for that yearly release. Like Alpha 1 went out on exactly the same Tuesday as Alpha 1 of 7.0, which is really cool. And yeah, so we should hit that annual release, and it's looking really cool. Like there's some really good features on it. We have still some RFCs in voting, which are pretty controversial, but it's going to be a loaded version. Like it's going to have more new features than I think the 7.0 did.
Wow. Was there going to be a lot of breaking changes in 7.1?
Not if I can help it. There's a couple of very minor ones. For example, changes to, like the one that was proposed yesterday was updates to reflection type, which will change a string response because of nullables being introduced, for example. There's a more controversial one around raising, if you pass in not enough arguments currently, you get a warning. They're trying to promote that to an exception, which I vehemently propose, but Joe, who's my co-release manager, he is in favor of for performance reasons. I guess we're going to battle that one out some more on the mailing list. But the goal is to be effectively backwards compatible. Cool.
Well, I'm sure we'll have an episode soon about all the nice, cool things that are going into 7.1 soon. So that'd be fun. And Ben, finally, I've putting you on the spot here, but this is something I keep forgetting to ask you about every time I see you at a conference or something, because you have this great package called the Uuid package that I've used in a lot of my projects, and it's fantastic for generating UUIDs. I'm curious, have you ever considered adding that, or is it even possible or conceivable to add that to as a core extension to PHP?
When I first did the library, there was a hackathon at PHP Tech maybe 2 years ago, and there were 2 or 3 people that were actually working on doing that. I'm not quite sure where that went. I think it would be fine to have as an extension. Unfortunately, I think that the problem with an extension is that it's just, in my mind, just can't iterate as quickly. So with Composer, I can require it and lock it to a version or upgrade it to the next version. And we're actually working on a 4.0 version of it right now. I'll be giving a talk at the Dutch PHP conference next week, and during the code night, I believe we're going to be working on the UUID library there. So the ability to iterate quicker on it and roll out with new changes and let libraries kind of pick the version they want to use and lock to that version is appealing to me. I don't know about how to everyone else. There is a UUID, there is a UUID. I can't talk today, apparently. There is a Uuid extension for PHP right now. It creates version 1 UUIDs and version 4, and it might do version 3 or 5, but I don't remember if it does the namespace UUIDs. But it currently, I think, only works on Linux, and that's because it uses dev random.
Yeah, there was actually a problem in your package, right? That the random UUIDs were being duplicated or something because it was using the OpenSSL random number generator, which wasn't super cryptographically secure after all.
Wasn't thread safe.
What's that?
It wasn't thread safe was the issue.
It wasn't thread
It
safe?
wasn't thread safe. Yeah.
Oh, it wasn't thread safe. That's right.
If you were running PHP in a thread, as we do in web environments, if that thread was spun off of the same parent, OpenSSL tries to use the process ID to avoid that kind of collision. But if the process IDs kind of repeat, if they recycle, then you can get back around to the same randomness that you had at the beginning. So you can run into collisions. I may not have described that very well.
No, it makes sense. It makes total sense. So sorry for the tangent and putting you guys on the spot, but I definitely was curious about those two things. So it wasn't enough to make a full episode, but enough to actually have like an appendage here. So I think it's fun. It's PHP related, so it's important. If you're listening and you have never gone to the website, at phproundtable.com, there's actually show notes for these episodes, and you can click on the links and stuff. And those show notes are really not all the episodes have show notes, but it's getting there, and it's all because people are actually contributing these. So if you're listening and you just want to as you're learning and as you're listening and you want to just write down notes or in Markdown format, do that and then submit it to github.com/phproundtable. There's a repo in there called show notes, and I want to give a huge shout out to Dominic Borderlin. I think I'm saying your name right. Dominic Borderlin. He did the show notes for episode 46, which is the character encoding in UTF-8 episode we just had just before this one. It was a really great episode, and Dominic set us up with all the links and everything that we need to click on for all the resources on that. So thanks so much, Dominic. And if you'd like to get a personal shout out from me on the roundtable for contributing the show notes, I will definitely do it. So we'd love to have you contribute the ones for this episode. And I always like to wrap up the episode with the developer shout out, which is a segment that recognizes a developer for being awesome in the community. And what we do is we send them a thank you note and a $50 Amazon gift card that is provided by Laracast.com. If you've never heard of it, it's a fantastic resource for basically all things Laravel, but also things PHP like testing and IDEs and things like that. Basically, you just go there, pop some popcorn and watch Jeffrey Way take you down the lane of happiness in PHP, and you can it's like watching Netflix, but you're actually learning something along the way. So it's an excellent resource. There's all kinds of anything you can possibly think of is pretty much on there. It's just he's very comprehensive library of tons of screencasts. So thank you, Jeffrey and Laracast, for sponsoring consistently the PHP Roundtable for so long. And for this episode, I was asking the panel to nominate somebody for the developer shout-out, and we nominated Jessica Mauran. And I don't know if I'm saying your name, Jessica. I mean, I'm saying Jessica right, I'm sure, but Mauran. Ben, why did we nominate Jessica?
I nominated Jessica because of her excitement and willingness to help open source projects improve their test coverage. She actually helped us on the UID library, and then a couple days ago she tweeted again that she would like to help any other open source project who needs help with behavior tests or unit tests to improve their test coverage. Excellent.
Well, thanks, Jessica, for your awesome the contributions that you're doing to make the world more testable. That's awesome. So, Jessica, I'll be trying to reach out to you and get your snail mail address so I can send this thank you card to you and get this Amazon gift card to you. And finally, to officially close this thing out, let's do some shameless plugs. Let's start off with Ben. You got anything that you want to promote?
Oh, let's see. Come back to me.
Okay, let's start it off with Davey. Do you have anything that you want to promote?
I don't know if it's a shameless plug. It's a relevant plug. I just want to push out Let's Encrypt again. Let'sEncrypt.org. You can get free automatable 3-month TLS certificates. They are supported in all common browsers. They support all the best ciphers, etc. And completely 100% free. And if you look at the stats, the amount of sites now under TLS is, I think, quadrupled or tripled since free Let's Encrypt came on the scene. So it's making a huge dent in getting SSL everywhere. So let'sencrypt.org.
Cool. What about you, Junaid?
Just anyone who's running a PHP local meetup group. I think anyone who's doing that is awesome.
True. All right, Ben, it's your turn.
Well, I am trying to find this website that I thought was really cool the other day. I can't remember the website information now. It's password shame something. Anyway, I found it really interesting because it allows you to find any of those websites that limit you to only like 6 characters or only alphanumeric characters, especially like bank websites and government websites that we think should be really secure, but don't let us enter secure passwords. And so it has a list of all of them and why they're shamed. So and you can submit new ones.
Sorry, I was just going. Is that plain text defenders dot?
That's not the same one, but I think there's several of them out there. I'm trying to find it. I'll send a link to Sammy about it.
Sounds good. We can put that in the show notes afterwards, and we'll have it at the very bottom under additional resources or something. Cool. So for our next episode, we're going to be talking about Docker. What is Docker? I don't know. We're going to figure it out. And we got some other cool episodes lined up without an official date yet, including event sourcing in PHP, which sounds interesting. I'm not really sure about this one, but we have a What Happened to PHP 6 episode that I thought might be kind of fun because there's a whole story behind that and like what went down with PHP 6. And it's very interesting. So, yeah. So if you have anything that
you have on that,
I'm sorry.
I have several names to throw at you. You should have on that.
Okay, perfect. That's great. I haven't even reached out to anybody on that one yet, so I'll definitely hit you up for that. So if you have something, what's that?
So I was just saying, I think there's a few PHP 6 books still on Amazon.
Yes.
So it's definitely good buying them while stocks last, I should say.
Indeed. So if you have something that you'd like to share about on the PHP Roundtable, some topic that PHP nerds care about, definitely hit us up. I'm Sammy K on Twitter or ping the PHP Roundtable. I'd like to thank Mr. Ben, Mr. Davey, and Mr. Junaid for joining us for this episode. And we'll see you folks in the next episode.
Thanks so much.